So today we're going to look at the short-run average cost curve when looking at cost of production. So first of all, just remember that the short run is the period of time in which at least one of the factors of production is fixed in its quantity. Okay, so let's just explain the short-run average cost curve. So when we look at the short-run average cost curve, and you'll remember this from yesterday's video, where we saw that a certain point was reached, I think it was 10 units, where when we made the 11th unit, we started to see an increase in the average cost. Okay, so your short-run average cost curve, this average cost is it's normally U-shaped, so meaning that every time we move down along the average cost curve, so let's say we say this is going to be Q1, so that's us producing quantity 1, and that's going to be the cost related to quantity 1. And you can see that if we move on to quantity 2, which is here, then we have a much lower cost of C2. And the idea behind that, we seen that yesterday when we saw every time we increased our number of units produced in our bakery, we seen a decrease. And then what we have here at Y is the optimum, the lowest point. So Q3 is our lowest point, our lowest point of the cost curve. Because when we look here at Q4, so we decide that's our 11th cake. So Q3 yesterday in our example was the 10th cake. So you can write this in if you want. And then Q4 in this case was the 11th cake, where we saw that when we made the 11th cake, we saw this increase in cost. Okay, so the cost increased again. And what we're going to look at now is what causes this. So how does it fall from here to Y, and then why does it increase from Y to Z? And then this line here, which is called marginal cost. Well, our marginal cost, MC, is equal to the change, so that triangle is delta, the change in costs over the change in quantity. Now, yesterday's quantity, we were just increasing every time by 1 unit. So because the bottom of that would be 1, we were just looking at the change in total costs. Okay, so I suppose that needs to be in there, TC divided by the change in quantity. Okay, so reasons why we see that downward slope from X to Y on our diagram. So the first reason is what's called specialization. So as more products are made, workers become more experienced and more efficient at making the product. They can make more products per hour, and as a result, unit costs are lowered. This idea of many hands making light work. Okay, so for example, in our bakery, you will have somebody baking the cakes and somebody decorating. And what will happen is, as they perform those tasks, the more frequently they perform those tasks, they find little shortcut ways of getting them done a little bit quicker, and as a result they can make more products per hour. So the second reason for that fall in average costs from X to Y is that fixed costs spread out over larger output. So as the number of units produced increases, the unit cost falls, and we can see that here from our example yesterday. We can see that from here to here falls, that's our average cost. So we have a total cost of 33 here. We only have 1 unit, so that means 33 is the average cost of producing that 1 unit. Then what we see is we have a total cost here of 38. Again, 38 divided by 2, we see a decrease to 19, and so on. And what we can see is that each one of these, so the fixed cost of producing 1 was €3. The fixed cost of producing 2 was €1.50. The fixed cost of producing 3 was €1 a piece. So we see that it falls each time. The upward sloping from Y to Z, so what we're seeing now is an increase in average cost when we look at that graph from Y to Z. Well, the reason for this is the law of diminishing marginal returns, and we've already looked at this before. So as extra units of a variable factor of production, so for the example here is labour, are added to a fixed factor, example factory, then eventually the average output will decrease. In our case, it may be that there's too many bakers in the one bakery, or if we have too many bakers that are trying to bake all of these cakes in just one oven. So remember, we had the case where our oven, it took 30 for each cake to be baked, and we could only bake one cake at a time. So again, just another example here, that 10 workers could make 10 products each, but 100 workers could only make 9 products each because they cannot work properly in the factory due to overcrowding. Okay, so some assumptions then with the law of diminishing marginal returns. So the first assumption is that it assumes the quality of the extra variable factors employed is constant. So an example here is that each worker, because workers' labour is a variable factor, each worker produces the exact same amount, which we know won't be true. Some workers will be more efficient than the others, some will work a bit quicker, some will work a bit slower, so that's not always the case. The second thing is that it applies to the short run only. So this is because in the long run, all factors are varied. So that includes, so remember we talked about chopped in the last video. You know, the idea that in the short run, they may only have one premises, that's our fixed factor. But in the long run, they'll have more premises. So the law of diminishing marginal returns may not apply. The last one is that the same production methods are being used. So, for example, in our example of the bakery, normal oven. So if we were using a normal oven versus a conveyor belt oven. So I don't know if some of you have ever seen this, where in massive factories that make cakes or certain foods, they have a conveyor belt. And what happens is it moves through the oven at a certain pace, and it cooks as it's moving, and then it comes out the far side. So it allows massive companies to put in a number of cakes at one time, and then they're cooked to perfection. So here's just an example using the table state after which the level of employment diminishing marginal returns set in. So we have the number of persons employed is 1, 2, 3, 4, 5. And for one person, their total output was 14. Their marginal output in units, we actually just leave that as blank. Okay. So we can put a little X through that. So on the second person then, we see that we have total output in units is 30, and that is 16 extra units. Okay. Then on the third person, total output in units over the 3 people is 50, and the marginal output, so the change is 20 units. So that's just 20 there. This is 16, and then this one here is 14. So we can see it sets in after the third unit. Okay, and that's the third person is employed. Or we can say on the fourth unit. So very similar to the law of diminishing marginal utility, but this is to do with the returns on additional variable factors. Okay, so just some important things to note about the relationship between marginal costs and the short run average cost curve. So you'll see that being written as SRAC. Okay, so when we look at our graph here, we see that. So we look at marginal cost. So at what point is marginal cost greater than average cost? Well, if we look at when marginal cost is greater than average cost, that means it lies above the average cost curve. That's going to be this section here. Okay, so we can see here, and we can even draw it in if we wish on the graph. If we pick any particular cost, and quantity, we can see that their marginal cost lies above average cost. And when we look at that, we can see that at that point, with marginal cost being above the average cost curve, marginal cost is rising. So as I move across here to different quantities, my average cost is beginning to increase, but also my marginal cost is increasing. So what we say is that when marginal cost is above average cost is rising. Now, the second thing then we can see is that when marginal cost is less than average cost is falling. So where is marginal cost on this graph? Less than average cost. Here, this part here up to Y is less than average cost. So we can see that if we draw a little line there. So if we say we'll take C1. Okay. Average cost is greater than marginal or less, greater than marginal cost. What we can see there, we'll call that C2. What we can see there is that average cost is greater than marginal cost, and at that, average cost is falling. Okay, so when we see that marginal cost, just to go back to the first one, is greater than average cost is rising, what you need to do is produce less. Okay, so if you imagine that's our 11th cake, we need to produce only 10, so reduce our production. When we look at marginal cost is less than average cost and average cost is falling, so that's this part here. Well, we can see that if we're here at the average cost curve, I could produce Q3, which is my 10 cakes in my example, and what I would see is that my average cost would fall. Okay, so if we have marginal cost less than average cost is falling, so produce more. And finally, when marginal cost is equal to average cost is at its min, so don't change. Or when we were looking at our example, that would be your 10 cakes.